And then question 7, find the determinant of a 3 by 3 matrix. So here I have the determinant of this 3 by 3 matrix. First row is sine x, and then cosine x, and then 1. Second row is cosine x, and then negative sine x, and 0. Third row is negative sine x, and then negative cosine x, and 1. So there are several ways that you can find the determinant of a 3 by 3 matrix. What I did is I expanded using the first row. It might be a good idea to expand using a row or columns that contain 0, but I just, for ease of illustration, I chose the first row. And this method works with any size matrix. So to expand using a row or a column, you choose any row, choose any column, and then you break down the matrix. You select the first element in that column, and every element has a sign, positive or negative, starting with positive in the upper left. So this would be positive, negative, positive, negative, positive, negative, positive, negative, positive. Moving left and right, up or down, the sign changes. So if I had chosen the second column, my first element would be a negative. You'd multiply whatever this term is by negative. And then I would have positive, which means that would stay actually a negative sine x. And then this would be a negative, meaning that I multiply it by a negative, and that would change it to a positive cosine x. Anyway, I'm expanding using the first row. So to expand using the first row, sine x is a positive term. And then you want to think of taking away that row and that column, and then write the matrix that remains, which is this lower right matrix, negative sine x, 0, and negative cosine x, 1. And then this second term, again, I said was going to be a negative, so I multiply it by a negative, negative cosine x. Take away the first row and second column, and you're left with cosine x, 0, negative sine x, 1. And then this last element in the first row is positive, 1. Take away the first row and the last column, and you're left with cosine x, negative sine x, negative sine x, negative cosine x. Okay, and now take each of those 2 by 2 determinants. You just multiply the, I guess that's a backward diagonal, negative sine x times 1, and subtract off the forward diagonal, 0 times negative cosine x. So that's going to give me my sine x times, this gives me a negative sine x minus 0, that's negative sine x. My second term is negative cosine x, and then cosine x minus 0 is cosine x. Then I have plus 1, and then my last determinant, cosine x times negative cosine x gives you negative cosine squared x, minus negative sine x times negative sine x. So that's actually 3 negatives because I have minus, and then each of those signs is a negative. Leaves me with a negative sine squared x. Okay, so notice I have negative sine squared x, negative cosine squared x, negative cosine squared x, negative sine squared x. So I see I have lots of cosine squareds and sine squareds. I actually have a negative 2 of each. So I factored out a negative 2, and that leaves me with a positive sine squared x and a positive cosine squared x. And I know that sine squared plus cosine squared of the same angle is 1. So that leaves me with negative 2 times 1, or negative 2.